Today we're going to talk about radian measure, and radians is one way that we can measure an angle. The other way we can measure an angle is in degree. So today we're going to talk about radian measure and degree and how to interchange between the two and a couple other important concepts. The first thing we're going to find here is what a central angle is. And a central angle of a circle is an angle with a vertex at the center of the circle. So we've learned to draw angles in standard position where the vertex had to be at the origin. Now we're going to talk about this central angle with respect to a circle. The central angle has the degree measure of the vertex at the center of the circle. So here's our degree. That's the central angle right here. The second definition we have is an intercepted arc. The intercepted arc is the length or the distance between the sides of the central angle. So if this is the angle, we have the length here. That's the intercepted arc. Now, in class we're going to talk about what a radian is with respect to the radius of a circle, but the idea here is a radius is a unit of measure, and it's really when you walk along the unit circle. But this is our intercepted arc, and it's a distance. It doesn't have to necessarily be on the unit circle. So intercepted arc is always between your angle, of your central angle, and the central angle is always formed with the vertex at the center of the circle. So the biggest thing that we want to learn here is how to convert between degrees and radians, okay? And there's two expressions that we use. So in order to go from degrees to radians, okay, whatever your degree is, you just multiply that by pi radians over 180 degrees, okay? If you want to convert from radians to degrees, you multiply the radians by 180 degrees over pi radians. And we're going to look at two examples, but in black here, those are our two expressions, and notice how they're just reciprocals of one another. I like to think about it as if I want radians, the radian unit of measure has to be in top, and if I want degree as my final output, the degree has to be in the top. And we'll see how these work in a minute. So here we're going to look at two examples, and we're actually going to convert from degrees to radians and radians to degrees. So our first example says, what is the degree measure of an angle of -3 pi over 4 radians? Okay, so we want degree measure. So we know that we're going to multiply our radians by 180 degrees over pi radians. And now let's see what simplifies and cancels out. The units cancel. Radians cancels with radians. Pi cancels with pi. 4 goes into itself once, 4 goes into 180 45 times. So we're really left with -3 times 45 degrees, and that's -135 degrees. So what that says is you can either have a distance or a unit measure of -3 pi over 4, which is the same thing as rotating the angle -135 degrees. So those are equivalent. One is degree measure, one is radian measure. And again, we'll talk more about that in class. So secondly, we're going to go, what is the radian measure now when we have an angle of 27 degrees? So I gave you something a little bit different here. Okay, not like a 45 or a 90, just 27 degrees. So we want that in radian measure. So we want radians, so notice how pi radians divided by 180. So the idea here is you simplify. 9 goes into 27 3 times, 9 goes into 180 degrees 20 times. So we're left with 3 pi over 20 radians. That's our unit of measure. Okay, so you think about walking 3 pi over 20 radians around a circle. Okay, that's the same thing as rotating 27 degrees. 3 over 20, that's a small number. Okay, 3 times 3, it's basically almost 9/20.
Again, sorry teachers, there will be a very, very important musical rehearsal this afternoon at 3:15. Please be prompt. Thank you.
All right, thanks, Ms. Moten. So the next thing we're going to do is, so we found how to convert between radians and degrees, and now what we're going to do is look at the length of that intercepted arc. Remember that intercepted arc is between the central angle. Okay, so for a circle with the radius r and a central angle of measure theta, that's theta, and it has to be in radians. The length of the intercepted arc is found by S is equal to R times theta, your radius times your degree in radians. Okay, so if we have a circle, there's a central angle in red. We have the radius, okay, and we're going to multiply by that central angle, and we'll get S. Okay, so let's look at an example. Now, we're going to use each circle to find the missing length. So we're looking for the length of the intercepted arc here. So our first circle, we have an angle measure of 3 pi over 4. Okay, and that's in radians. Our radius is 2 centimeters. So our length of our intercepted arc U is going to be equal to your radius, which is 2, times your theta measure in radians. So that's 3 pi over 4. Well, the 2 and 4 simplify, so U equals 3 pi over 2 after we cancel out. Okay? In our second circle, we have a radius of 5 units and an angle measure of 2 pi over 3. We're looking for C here. Remember that the intercepted arc length is equal to R times theta, and that theta has to be in radians. So 5 times 2 pi over 3. So we just substitute and we simplify and we get 10 pi over 3. Can't do anything more, just leave it as that. So that length of that C, that intercepted arc, is 10 pi over 3 units. The other thing we're going to do here is we're going to find exact values. In our last unit, our last section, we talked about standard form, and we found, I think, sine and cosine of 60 degrees. Well, now let's look at what are the exact values of cosine of pi over 4 and sine of pi over 4. So notice how we have theta in parentheses. When we put in parentheses, that's function notation. I have my theta, so I'm not looking for an angle measure, I'm looking for an x or y coordinate. Okay, so I've drawn my unit circle here, and now I've drawn a 45-degree angle here in red, pi over 4 units, and I know it's pi over 4, it's half of pi over 2. Half of a quarter, or half of 50 cents is a quarter, so I know that 1/4, pi over 1/4 is half of pi over 2. So if pi over 2 is equivalent to 90 degrees, that means pi over 4 is 45 degrees. So let's use that. Pi over 4 is 45 degrees. So I'm going to construct the 45, 45, 90 triangle. So here's 45. There's my first angle. I draw a vertical line down from point P down, and that's 90 degrees. So you have 45, 45, 90 degree triangle. The lengths are x, x, x root 2. Now, the hypotenuse, this is the unit circle, the hypotenuse is going to have a length of 1. So I know that x root 2 is going to be equal to 1. So I set that equal to 1. So x is equal to 1 divided by root 2. Rationalizing the denominator, we get x is equal to root 2 over 2. So if x is root 2 over 2, we've labeled across from the 45-degree angles is x. And we know that the hypotenuse is 1. So if x is root 2 over 2, that means these two lengths are the same. They're both root 2 over 2. So the cosine of pi over 4 is root 2 over 2. And the sine of pi over 4 is root 2 over 2. Okay, so again, be careful. If I know the angle measure, whether it's in degree or radians, and I want to find cosine of an angle measure, sine of an angle measure, I'm looking for the x or y coordinate. Okay? If you guys have any questions, go ahead and email me below, or you can just make comments as well. We'll see you next time.